Hey, Shai, and Shai is pronounced correctly.
Yeah, perfectly.
Very good. This is not common here. And of course, I invited you, to really find out what is your first computer actually.
Well, it's a Sinclair Spectrum, but I actually downgraded to a VIC-20, so which is a funny thing. Ignorantly downgraded though. The first computer, me and my best friend, who you interviewed a decade ago, Hen Fishbane, we both had a Sinclair Spectrum, which was an amazing computer, as you probably recall. And a year or so later, after we were already programming with it and, having lots of fun with it, my uncle saw it and said, this computer is so small. There's a much bigger, way better computer because it's bigger, obviously. So, and he brought us a VIC-20, which is like the younger, crappier brother of the Commodore 64. And it wasn't as good as the Spectrum, actually. The Commodore 64 was great, but the VIC-20, not so much. So,
but it looked similar, right, to the Commodore?
Yeah, it looked very similar in terms of memory and everything. It wasn't nearly as great. And it wasn't as accessible as the Sinclair Spectrum. I mean, we programmed the Sinclair Spectrum without actually knowing how to write yet at that age. We were 5 and 6 years old. So we didn't know the alphabet properly. And we were able to use the Sinclair Spectrum because it was that simple. And the VIC-20 was a more traditional computer. It had a more typical keyboard without the commands on each button, and you needed to actually type out everything. It was a big step backwards in that sense. But then I moved to the Apple II, so that was good. And
one question,
and all went well.
You said your friend, which I interviewed, was it Shen Fishbein, right?
Hen, yeah, that's a harder name to pronounce. That's impossible. It's Hen. You can't say it physically.
Hen.
No. Close.
Okay. And it was in 2013. It was an interview. So I interviewed him about Codename 1.
Yeah.
Exactly. Codename 1. Exactly. And you are saying that this is the guy with whom you had fun with the as you were five years old?
Yeah, we both learned BASIC on a Sinclair Spectrum back then. Which
it's a great story. So you have a lifelong friend, right?
Literally lifelong. Like from the moment I was born, babies in the crib next to one another, door next to the other door, and to this day, best friends. So
this is actually incredible. Yeah.
Yeah, pretty much so.
Yeah, I interviewed him in 2013, and now I'm talking to you. So it's actually really nice.
Yeah, continuation. Yeah.
Yeah.
Yeah, and he's a repeating figure along my journey, which his was more twirly in terms of computers, and mine was more of a direct line, not straying as much away from our industry. So
the last time I saw you in person, either you or Hen, was at Java 1, and one of you wore suit with a tie. So you look really serious.
Probably
I don't know whether it was you, maybe. Probably
sounds
you.
more like me if I did that.
And you had a meeting or something, right? So like investor or whatever. It was one of last Java ones at Sun Microsystems. So the last time I met you, and it was something with
Makes
Java
sense.
and Codename.
If it was 2013, then it's probably when we're trying to raise money for Codename 1. A spoiler, didn't get any. But
you
we
looked
had
really
lots of
serious.
meetings then.
So you looked really like
I'm a very serious person. You can see I'm totally a very serious person.
Yeah. But you looked like how is the guy from Oracle? The chief Oracle, Larry Ellison.
McNeil?
So you look, Larry Ellison. But Larry Ellison doesn't wear a tie. So you looked really perfect. So
thank you.
Yeah. And I met you.
I never wear a tie, so you saw one of Hen's wedding and that's about it.
Yeah.
So I
also remember where I met you. It was the the bridge between where the Sony is. There's a specific name, this Sony Theater and in San Francisco, and there's the bridge to to Moscone, and this is where we met the very last time. And I don't know why, I just remember, because we had a chat with Codename 1, whatever, and then I met you, and this was like, and I was like, okay, hi. And you said hi.
Wasn't it on the carpeted area between where they have these outside parties between the Moscone centers? Was it
there's the Sony Theater, there is like, some tea, there's like on the other side of Moscone Center, it is a specific name, the area. There were some, tent areas. There was a party one time.
Yeah, I think it was there.
Yeah.
But my memory might be hazy, It's,
sure.
It's been a busy decade.
Yeah. Okay, and you started to program with Hen Spectrum, or you played Basic, or you played games, or what's the story?
Basic, we didn't. My parents never bought the tape deck, so we had absolutely no other option other than to write code.
You didn't bought it on purpose?
Yeah, I guess so. Although it's hard to tell. They weren't technical people, so they sort of, you need to buy the kid a computer, so they bought a computer. The idea of a tape deck, I don't know if it was intentional or have no idea. And there's no one to ask by now, so it just wasn't there, and we programmed.
But it was actually great strategy that it worked out. So because it couldn't work out. It could happen that you would lose interest on computer, but it was other way around, right? I assume you wanted to code your first game, my assumption. Is it true or not?
Yeah. Pretty much so, yeah. We learned how to change the shapes of ASCII characters so they'd look like cars, and made them sort of drop from the top so it feels kind of like you're driving in a road very badly. And that's the extent of my memory of that period. We didn't do graphics then. I don't know if it wasn't an option or what. I distinctly remember that you could define a new shape for an ASCII character there. Which was pretty nice, and use that as sort of a makeshift car. That was it. Later on, I moved to the Apple, the 68K computers, and the Apple II, etc.
But did it work, the game? Did it work at all or not?
Work is a really wide spectrum there. So you typed in run and ran it, and something ran. It was just what 5-year-olds consider to be entertaining.
5-year-olds is incredible. I mean, that you can even type proper things. But you're right, with Spectrum,
something at random. Yeah.
The keys were like macros, right? Well, remember, R
exactly.
was like run, L was load, so you couldn't with
just
one
needed to remember values, and someone showed you how to do something, and then you were able to do it. You didn't even need to know how to write, which we didn't know at that age, and definitely not in English. So we somehow, I have no idea how we were able to do that, but that's a very strong memory, and it's definitely not something from our parents, because both our parents can't use a computer in any way, shape, or form, to this day. So there's no risk of that seeping in. So somehow we got that working. No idea.
By the way, I remember the name. It is Metreon where we met. Metreon is the name of the area. It was the Sony on the other side of the Moscone. There was like Sony Theater, and there was like some bars or something like this. So Metreon is the name. Okay,
and then you started old Moscone.
Yeah, and you started then. Why you got the Apple then?
So we years moved by, and Spectrum sort of went out of vogue, and computer classes that I started taking at 8 or so were on the Apple, so I moved on to that. And people told me, that all games are written in assembly, so I said, okay, I'll learn assembly language. And so I started a class at 68K assembly, and learned how you can burn a monitor on a 68K Apple II, which I assume you can. At least back then I believed that I did. It's learned all sorts of programming languages then, Pascal, assembly, these sort of things. And and then proceeded, later in the following years to, Turbo Pascal, computers, and all of that journey.
Did anything interesting happen on
everything.
Spectrum, or was just the attempt to write a game and
Just the attempts to write a game and everything. We were too young for that to do anything
And on the Apple?
really serious there. I was too young.
Okay.
It's sort of the experience. I got some of the ideas at the age of 8. It's really hard to understand bases, and I got it at that age, but it was too premature to be of any value. And I think it only started sinking in when I was approaching high school, when I started my first BBS. And,
What is BBS?
Bulletin board system,
okay.
the
Okay, this is
dialing.
what okay.
So
I thought this is like class in a high school, but no. Okay. This was the precursor of internet, right? The BBS is like
You didn't have one?
No. I was
Wow.
later to game. I got internet later, and before internet, I did computer stuff, but internet came late. So my first internet connection was with robotics modem, and it was almost fast connection already, 33.6, what I remember, kilobits.
Yeah.
Right.
My BBS was 1,200 baud, so 1.2. I built essentially a BBS, which was on the shared phone line at home, because we didn't have 2 phone lines at the time. It was back then.
Yeah.
And people would just, between these hours, you can dial into the BBS, and people would dial in, and you chat with them. It was nice. And then I did computer science in high school, and started my first job at about 16.
Wow. Where was it?
Which
city?
So it was in a city near... I was living in Kfar Saba back then with Chen, and it's which is sort of a suburb of Tel Aviv.
Okay.
And this was in sort of nearby city, but it wasn't on location. It was for an educational center where they needed to build a game for kids. And back then I was doing lots of DOS programming with game programming and that sort of thing. So we're doing, double buffering, and sort of there was a special video mode in x86 in Intel DOS for sort of a 240 by 320 VGA mode, where you could render alternate lines but do a hardware buffer flip with double buffering, which was really cool. And I loved hacking those sort of things. So I built a game on that for that company.
But you built a game now, your first proper game, right?
Yeah, first proper game. So the guy hired me to build a sort of a simple teaching game for kids, where you sort of fire something, I don't even remember what, sort of fire sprites on things and get points based on solving the right answers for simple mathematical games, questions. And here's a kind of a tragic story. So this person hired me. His name was Moshe. And he sort of gave me the job as a contractor and promised me a certain amount of money. And I started working on it, built the whole thing. And then, one day we had one channel back then. There was no multiple channels or things like that. One channel for the entire country. So my mother was watching the evening news, and she was like, "Isn't that your job over there?" I was still in high school, so I wouldn't go to the job. I just, I met the guy like 2-3 times overall. So isn't that where you work? And I go to the TV and I see the place where I work, and then the picture of my boss, and he was shot and he died. Yeah. And apparently, just a convict on vacation, looked through his drawers, pulled out a gun that he owned and killed him, in the struggle later on. Totally random thing for that guy, and sort of that's how I lost my first job.
Okay.
Not pretty tragic.
Yeah.
But, yeah.
But this was like not a plan. The other guy just shot without a reason, right?
No, just without, that year and the year later were the only two cases of people I know who died from firearms. And, I feel pretty strongly against firearms since then. It's totally random. Both cases, people just, got shot.
Okay.
And that's kind of, I tell the story about my first job in that sense, and it's kind of weird that it ended in that way.
Yeah.
I don't even know how to process that, even after all these years. Anyway,
so what you did then? Because you had the code, right? But it was useless.
Yeah. I gave it to them, and they gave me a check, but I don't think they ever used it. He was the only one that was running it, and no one knew me really. So I don't think they ever did anything with it. It was super embarrassing for me as well. I didn't really know how to process that, because the first time I knew someone who died, and at 16 you don't exactly have the emotional capacity to really internalize that sort of situation, and it was a pretty
but it seems like it was a nice guy.
Situation. As far as I remember him, he was a super nice guy, and very tragic.
So what happened then?
Don't buy guns.
No.
Anyway, so yeah.
So you're absolutely right, because if you have a gun, it is either useless, or if you use it, it's even terrible, right? This is like
it's usually used against you. That's a statistic, against you or against someone you love. So don't buy them. Anyway, so after that, I worked sort of as an instructor in some places, teaching computers, programming and stuff like that. I used to hang out in a computer store and do all sorts of that sort of stuff. And then I got drafted to the military. And while I was in the military, I got another job. So I worked for a company that did... you remember Paradox by any chance?
Yeah. So, Paradox is
we did Paradox stuff. Yeah, it's a fantastic. It's not just the database. There was DBase, which was very popular back then, and Paradox wasn't as known, but in many regards it was superior. The idea is kind of very DOS-like. They tried to do a Windows version, but it never took off the ground because it was so different. And by the way, during that time, one thing I neglected, I was Team OS2. If there's listeners who are into OS2, I was really active on Team OS2.
OS2 Warp,
and
right?
Yeah, before Warp. Warp was way later. I was OS2 2.0. I installed all the adventurous stuff there, and I was installing Linux and Slackware Linux like before Red Hat was a name. I was very big on alternative operating systems. My friend and I installed Solaris x86 back when we were in high school. So we were big operating system junkie.
Similar here. So I wanted to have Unix for C++, but it was impossible to buy Unix. So I started with Linux. And it was before the Slackware, I remember, and there was German Linux distribution, DLD, very early. Also used that, but it was crazy. What I remember, I have to disassemble my machine to find out the chip number. We have to put, to the Linux installation. Then I got, got it working. So it was crazy times. So this is what I remember. And I will also remember an operating system, an alternative one, which was supposed to kill Apple. And it was object-oriented, and you could actually buy it. I forgot.
What?
BOS.
BOS.
Exactly. BOS.
Yeah,
exactly.
BOS was
so
fantastic.
I wanted really to buy it, but then it disappeared. So I actually saved money.
Yeah.
It's now I will buy it. It was a nice box. It looks great. It looked great, and I wanted to have it, right?
Yeah, it was a fantastic box. I never got it either. But the concept of an operating system written from the ground in C++ and very object-oriented microkernel concepts. The story that Apple wanted to buy them. You're familiar with that?
No.
So, yeah. You're not familiar with that? So,
no.
The founder of B was Jean-Louis Gasset, if I remember correctly.
Okay.
And he was a former Apple executive, and he sort of formed the company. And when it didn't really take off, because it's really hard to build a computer company from scratch, Apple wanted to buy them. Back then they had Mac OS 9 and were looking to upgrade to something new. And they were constantly failed in building the next generation operating system. So they decided to do an acquisition, and they tried to buy B. And it was literally at the stage of deciding the amount of money during the negotiations. They were debating how much B would get and at what conditions. And then they did a 180 and bought Next. Another company founded by
from Steve Jobs.
Apple executive.
So they bought, Steve Jobs at Next. This is familiar, but I didn't know about B.
So they used, I guess they used both one against the other to sort of reduce the sales price and to pressure both into the sale. Eventually, they bought Next. I always wonder what it would have been like if they would have bought B eventually, what sort of alternate reality would have ended. Yeah. Because B, in many regards, is a superior operating system to Next, although it's pretty amazing what Apple did with what Next actually built, because Next has lots of baggage that you still see to this day inside the iPhone. You know, if you've programmed it for the iPhone, which I have a lot, it's all NS string, NS that, and it's all next step. Right? Exactly. Yeah. It's all still there. All the CRUD is still deep in there. All of that logic of message passing and things like that are sort of inherently built in, and all of that overhead. It's there forever. Yeah. And it's pretty amazing that they were able to take that old code base and constantly adapt it to every form, every step along the way. It's a spectacular journey.
Cool. So now back to you to Paradox.
Yeah. So I was working for this company that was doing database applications for people. And for those unfamiliar with Paradox, it's sort of an Uber application, a really, really complex application with all the menus. And to program it, you just select menu entries and then you hide the menus. So it's just every command is in the menus, and you sort of write the command based on literally stepping over the menus and making selections. It's hard to describe that without actually showing it.
Sounds like a visitor pattern mixed with command.
It's a very non-object oriented, non-GUI way of programming, and very discoverable, because every feature you have in the application is in the menus. So you just search through the menus, you find the functions that you need supported, and then you just call them through the menus, supposedly, and then just make the menus disappear, and then you have an application. And it's super easy to build very elaborate forms and applications with it. And we did build these sort of applications while I was in the military. I had sort of a relatively easy service where I could be at home some of the time and be in the military some of the other time. Okay. And I could sort of program. I had a laptop, so I could take it with me to in the military and then come home and do some work on site. And I did that sort of work there. Also took it with me to guard towers and things like that.
But this is actually sounds like fun, because usually it is a waste of time. But if you have a laptop with you and you do something productive, it's a great feeling, because the time is not lost.
It made my time much easier, and I think the record on my base for the most amount of time of guard duty ever. So like I had the first year of my service, I did over 1,800 hours of guard duty, which is considered a lot. It's, some days.
Now we know when the next version of Paradox happened, right? So it was directly related to the versioning of the software. Yeah, productivity.
So back then I still worked in DOS for Paradox, because the Windows version, there was Windows around at that time by then, and it was quite popular, but not for business applications yet. So lots of business applications were still in DOS, and Paradox on Windows kind of sucks, so they didn't use that. So I had that job during the military, and then when I got out, I started working for an AI company that did sort of scheduling AI, which isn't, back then, We had two separate projects. One of them was a really nice sort of logic-based AI, which I didn't work on much, that was called Logist. And in it, you built rule-based systems. But the cool thing about it was that it was able to explain the logic that it took. So, for instance, if you built an AI system for a loan, and the system decided to reject the loan or to accept the loan, it could then explain the logic of why it made that decision, right?
But this is years ahead, because now we have the problem that all the decisions are not explainable, right?
So the problem with today's systems is that they are trainable systems. So the problem is machine learning. Machine learning is terrible because it doesn't know how to explain. It sort of works. This is the type of AI, that sort of classic AI, the really old AI, where you actually had to write down the logic. It wasn't a trainable system. But then as you wrote the rules, the machine could then explain them back to you because you wrote the rules clearly.
And is it similar to the RITI algorithm and Android, for instance, from JBoss, where you had to know, like a memory, you can put the facts into the memory, and then you ask something, and you walk through the facts.
It's a rule system. Exactly, it's a rule
Exactly.
system. So there's several systems like that today. I haven't kept up with the current stuff there, but that was back then. One of the problems was that it was written in Hebrew, because it was initially written for the military. So Hebrew is kind of a terrible language, objectively speaking. And one of the problems with it is that all the verbs and nouns are sort of reversed when you compare it to Latin languages. So
wait a second. The project, I was wrong. It was Drools from JBoss. Drools?
Yeah, right.
And this is what Drools, not Droid. Drools, of course. And this is where we had to use the problem was only you never knew which rules become active. So this was the, because you put everything to the memory, and it was executed, and then you knew, okay, something happened, but you never knew. And the RITI algorithm was the optimization. So this was the idea. But okay, so this was Drools for the listeners. The JBoss Drools.
So,
okay.
Yeah, so this knows how to explain why it came to the conclusion. And that was pretty revolutionary, only the problem is it only worked in Hebrew. And if you just translated the words literally, it would write down the answer in a way that looks really weird, where the words, the verbs and the nouns were completely mixed, because it was really, there was no language model that was separate. It was very mixed in with the language model.
Yeah.
So they tried to adapt it to English, but it was written in like really deep old C code that was written for OS2 actually. Amusingly enough, because it was like this really old project and it sort of carried on. And the other project, which was what I was mostly working on, was a scheduling system. I don't know if you're familiar with heuristic scheduling and stuff like that. It's a branch of computer science where you sort of have problems that are not necessarily solvable, and you sort of walk through the tree of solving the problem. Now, heuristic search is digging usually depth first, based on a certain heuristic, a certain logic of direction to find the right solution. There's all sorts of other approaches to solve this that we did.
Is it a sophisticated form of backtracking?
Yeah. We supported backtracking. We supported weights to determine the direction of the search. So you could tune sort of like an equalizer, the amount of weight you wish to place on every one of the heuristic rules, so you can balance them mathematically to get an optimal solution. And one of the first examples of a project that I did was for the City Hall in Tel Aviv here, where I scheduled students moving from grade school to middle school. So when you move from grade school to middle school, you pick your friends, and then they place you in a specific classroom. Now, there's several other constraints, like they want a relatively identical number of boys and girls between each class. So there won't be a class of all boys and the class of all girls, etc. You'd also want grades to be a similar average. So you won't have a class of really smart kids and a class of all the kids who have experiencing difficulties. You'd want everything to be sort of even. So there's all sorts of rules like that. And we defined all of those rules, and then you just search through the problem of all the children and all the combinations and sort of go through the heuristic to find the ideal combination where kids can be with their friends and yet be distributed between the classes in a way that's very fair to all the kids. And that's an example of such a problem that I solved. I also worked with Intel on
now I remember, because scheduling, I thought about something different. But you know, a schedule like the plan of students, this is a known unsolvable problem you should learn during your study. There's the traveling salesman problem. There's such the scheduling problem.
Exactly, that's a scheduling problem.
Oh, okay.
Chess is a scheduling problem, right? So chess is a scheduling problem, and you can solve it with a heuristic as well, the same way, the same exact way. And it's a really cool problem overall. There's lots of solutions for that. There's today, back then there weren't many, so we generate sort of Gantt charts showing how to schedule people and all sorts of things like that. And it was a pretty fun sort of set of projects that we did for all sorts of companies. I worked there for Intel, which has a very complex scheduling problem with their machines that do work on the wafers. They have various types of machines that process the wafers along the way, along the manufacturing stages. And they have one of these machines has two arms. And you want to use both arms to the maximum. The problem is that if one type of wafer arrives to arm 1 and another type of wafer arrives at arm 2, you can't have that. It needs to be specific types so both arms can be utilized simultaneously, kind of like a CPU, superscalar CPU scheduling issue with multiple pipelines, same sort of thing. You need the right wafers to arrive at the right time to maximize the usage of both arms. Yeah. And for that, you need to go all the way back to the machines that bring the initial wafers and put the right sort of batch of wafers there. So it goes through the pipeline and the machine with two arms gets the right sort of wafers.
And then you have to really probably go one step back again, to optimize the orders and
So that's another example of project I worked on that was very elaborate in that sense. After that, I was very obsessed with this was in C++ and Visual Basic for the UI. Okay. But I was working with Java on my spare time quite a lot. Back then, I was writing articles about Java for EDM2 back then and was hacking with it in my spare time.
Which version was it? Do you remember?
This was the first beta I started working on, and then kept going with that. I started writing articles for 1.1, I think. That's when I started writing about it. Then
why you like Java? Because it's always interesting because you are so skilled with C, all the programming language, and Java was primitive.
So I was working a lot with C++, and back then I still liked it, but I felt it was a bit problematic in many regards, but I still liked it. It's only in my next job that I developed a deep-seated hate towards C++. And then Java sort of, it's so much easier and so much nicer and so much more fun. When I started working with Java, I was still at that time I was working with C++, and it was an okay language, very powerful, and I liked the power because I was young. But I still loved Turbo Pascal, which was a fantastic environment. It was so convenient and so easy. And Java was the first time where I felt that the language was very reminiscent to me of Pascal in terms of ease. And the other reason I loved it was the portability, because I'm a big OS geek. So the portability to OS2, to Linux, to the platforms that I love, made it a big difference for me personally. So and the connection to the internet, to applets and things like that, I really liked those abilities, because back then there was no other option to do something dynamic on the web. So applets were a big part of that. There was no server-side Java or anything like that. So that was the thing that attracted me. So, but I was very much attracted to Corba, and this was something that goes way back. I don't know if you remember OS2 had SOM, which was sort of an implementation of Corba with which they implemented their desktops. And I was very big on distributed computing and Corba and the whole ideas behind that. There's so much, open doc. I studied all of those things so deeply, and all of that knowledge is now.
Open doc was supposed to be revolutionary, right? So the open doc was
it was essentially OLE, but far more elaborate, network distributed sort of OLE. And it's sort of vaporized at some point. No one ever implemented it properly, and it just stagnated and vanished.
For me, it's interesting. You mentioned Corba. So I started with RMI, which I really like, remote method invocation in Java, because there was like naming.lookup and you were done. And then companies wanted to have Corba, and if you look at the Corba, it was way too complicated. In order to get the naming, you had to look up the naming service. If you have the naming service, then you can look up the stuff. And in Java was one-liner. With Corba was like 5 lines. And so this is just crazy to have the same thing.
5 lines is lucky with Corba.
Yeah, but we did already some optimizations. But also, the narrowing. So there were some problems with pass by reference, pass by value with Corba, and with RMI, everything was solved. It was just beautiful. I never understood why someone said, because of interoperability. But in my projects, everything was Java. So who cares? One time can it be C++, but it never was. So this was my. So I didn't like Corba a lot.
I did it in C++ back in the day. So
okay, this is different.
Before there was Java.
Which Orbix?
Obviously,
Orbix or Genix? Orbix.
I did it in SOM back then. Even before that. So SOM was built into OS2, and it was the implementation because OS2 had an object-oriented desktop, sort of like you'd see in Mac or Windows in a modern operating system. And it did it back then with 4 megabytes. And the way it did that was through Corba. Everything was an object, but it was written before C++ was a thing. So it was written in C, but it used Corba as sort of an object-oriented implementation of all the objects you saw on the desktop. Okay. And so it was instantly distributed and cross-process, which was a very powerful thing.
Yeah.
And the workplace shell, it was very powerful. It was very fast, which was amazing, and low overhead. So when it came to Java, I did use RMI, but I also used Corba, and I was used to it by then, and I understood the logic. So it didn't bother me to write an IDL file and things like that because I was familiar with them at that time already. And I liked the idea of distributing. So RMI was nice, but it always felt to me like something overly simplistic to some degree because it looked at Java as sort of Java solves everything. And also it has the problem of serialization, which is flaky.
And distributed garbage collection. And distributed garbage collection. Because, all the clients... Yeah.
That solved the problem. That was amazing, though, because in Corba, you don't have any... you create objects and then suddenly, who handles that? Where is it? You need to manually delete it. And that was terrible. But, it is one of the things I really liked doing. And so when there was a job opening to do distributed systems in Corba for satellite image processing, I jumped on the opportunity and I went to the interview. But I made a crucial mistake, and I read a book on my way to the interview on the bus. I read a book about distributed agents, which was also a really cool subject at the time. Back then, agents...
You remember Egglets? Do you know the Java agent from IBM environment, Egglets?
I remember vaguely. I mean, this predates that quite a bit.
But with Corba, it was hard to build agents. With RMI, it was easier because... I don't know whether you remember. Sure. There was marshaled object, and marshaled object, you could move bytecode with the state around because the marshaled object was, the class loader was included, so it was able to download the code. From security perspective, not that great, but it was a true agent back then. So I wanted to use it, but there was no use case, right? This was the problem. So So, but what happened now?
This was less about agents. It was more about AI agents. It was more like about small intelligent elements that were designed to sort of create a hive mind approach to solving problems. This was how people like 20-something years ago believed that we'd solve problems in the future. Lots of each agent pulls in his direction, and essentially you get a sort of hive mind approach to solving problems by creating lots of simple solutions. And it was
intelligence
something
of the
I was
crowd back then, right?
Exactly.
Intelligence of the crowd.
Exactly.
Back then was a huge deal.
Yeah. And I was obsessed with that. I was sure all AI in the future would be based on that, and I went really really enthusiastic about that idea to an interview about call-bound distributed systems, and I didn't stop talking about that. And I still got the job, which was amazing, with a company that one of the reasons I really wanted to work there was that every desk at that company had a PC and an SGI machine next to it. You remember those SGI, those purple SGI machines?
The Ozone, right?
It was. I don't remember. Here's the annoying part there. So I was looking at that office, and we go through that, and it's a fantastic office with all these SGI machines everywhere, and I'm like itching with my fingers to play with it. And he says, so okay, the project will only start in 6 months or so. So for now, we're just going to put you in a different project over there. And they assigned me to a different project, and eventually the project for which I joined them got cancelled. So I got stuck with that. The company never worked on an SGI machine. Sort of got screwed on that one. And that kind of sucked. But I did get to work on a flight simulator.
Okay.
And to this day, there's a couple of flight simulators from Electronic Arts, and you can see me as one of the pilots in those flight simulators, because we had like 16 pilots working at the company doing testing it and defining the missions and everything. But you can't take a photo of an Israeli fighter pilot because of matters of national security. Okay. Right? So they took photos of the programmers and pretended that we're fighter pilots. And there's still photos of me, standing there with the uniform and everything, like I'm one of the pilots.
Wow, they were a true pilot, no? All the true pilots, were sad. Yeah. And you became, you gathered all the,
I got the photo, but to be fair, they wipe the floor with us when they're playing the game. Really? I'm not a huge, unbelievable pilots. There's one thing, it gave me some confidence about the day-to-day security, because we'd go, my friend and I, programmers, would fly planes loaded with missiles against one pilot only with guns, and he just wiped the floor with us until he ran out of fuel. Like
this was always my question. Let's say the Formula One, how good the drivers actually are. Can kids, for instance, whether the kids, for instance, can have something against them, or pilot, also interesting. So you had no chance; they were as good. So
the pilots there were so amazing. The level of reflexes and attention to detail and the ability to keep their mind on multiple things at once, it was absolutely fantastic. It was so good, and just with guns. And nothing else.
Were they also nice people or arrogant? So what was?
Depends. It depends. There's a wide range, but there is a definite character. You'd see all the huge motorcycles in the driveway. Really. But there's a wide spectrum of personalities there still. But in terms of their skills, at least as pilots, they're all really, really, really good.
Oh, and was it a game what you built or true simulator?
Yeah, so we took code of a simulator that was built for military purposes, actually. Okay. And we adapted it to be a game. And it was written in C++. And it was a huge code base, very big, and legacy. It was built before people really knew what C++ meant and what it meant to write object-oriented code. So, they had an entity representing an airplane, and it sort of multiple inherited all the qualities of an airplane with multiple inheritance. Okay. And it used virtual inheritance to sort of work around the problems there.
So you never knew which method was invoked, right?
Oh, you don't. Not just that. If you're not familiar with multiple inheritance in C++, the problem there is that C++ sort of aligns the object as pieces in memory, one next to another in segments. And so if you have state in the object that you're inheriting, which you're allowed to have that in C++, then that state will just be placed one next to the main object multiple times potentially. And that means that when you downcast, it might cast to the wrong instance of the state. So you need virtual inheritance to sort of, in runtime, interpret the right inheritance instance and sort of use that. But this creates all sorts of other problems because essentially it's only one class that's interpreted in runtime. There were so many problems there. Also, const correctness. There were so many headers, and they built it to be const correct. And when you wanted to change something that was const, you had to go back so deep to fix everything. And every build is like a couple of hours. So, and if you change a header, it recompiles everything.
Yeah.
So it was a nightmare to maintain that. And
this is where you became Java fanboy, I guess, right?
Yeah. That's so. There was a weekend where the company, all of it, decided to go to Sinai Desert for. Actually, it's not exactly a desert; it's a beach area, but for a vacation, and they all flew there. And I decided not to go because I hate the beach. And I took the weekend and came to the office over the weekend and did a refactoring. Because back then we used to use SourceSafe for version control, if you remember.
Yeah.
So you'd lock files, and the problem is that you can't really do refactoring because people would always have a file locked in place. And if you want to change something, you need to change everything. You can't. You'd lock the entire system. No one else can work. So I used that weekend. I came in and I refactored the entire system and eliminated the multiple inheritance in that entity. Completely changed every file in the system. And once I did that, it worked much better. During that weekend, apparently someone broke into the office and stole one of the computers, a few of the computers, but the one literally in front of me. And when I came in on the Saturday, I noticed cables were torn, but I sort of ignored that because I'm focused on my work. But, we were literally burglarized, and I didn't notice that. But that reminded me of something I forgot. In the previous job, I used to come in like at 6 a.m. sort of thing, habit from the military to get up early. And I was working, and usually someone would go out and smoke, and the smoke alarm would go off, occasionally. So I just shut the door because, it's annoying. I kept working, and after a while, the lights went off, which didn't bother me because I still had uninterrupted power supply. So I kept working, and I'm working and everything, and suddenly my computer goes off. The uninterrupted power supply ran out of juice. So I opened the door, and I see this huge fire hose going through the hall. And apparently the building's on fire. Oh. And I sort of ignored the alarm. I said, someone's smoking, just close the door. And the building was on fire. And I'm like walking out the building, and suddenly the phone I had with me rings, and it's my mother. Your office is on fire. And I'm like, yeah, I just found out, Yeah.
And you could walk out, or what's the story?
Yeah, I could walk out. I walked out and there's all these fire engines outside and everything. It was one floor above me, so I didn't smell anything.
Okay.
And not exactly above me, so there was no heat or real risk. But it's amusing that I was in a building that was literally on fire, and I didn't.
So your
didn't
code
notice
was
until
on
my
fire.
computer went off.
Your code was
my
on fire.
code was distracting, and I didn't notice anything other than the code.
What was the name of the simulator you built?
So it's for Electronic Arts. It was Jane's. It was Jane's IEF, the IAF. Sorry, the Israeli Air Force, and later on USAF. So one of the nice things about it, it's. There's all sorts of levels of simulators. It's a a mid-range simulator, not too easy, like Afterburner and things like that, or just gameplay, unrelated to flight. And there's Falcon and stuff like that, which is so complex you need to actually know how to fly a plane to fly it.
Okay.
So, and Microsoft Flight Simulator as well. So ours was somewhere in the middle, sort of trying to give you decent gameplay, but still being relatively realistic for that fighter pilots do enjoy it and understand the relation to reality. But one of the things we had,
what I said actually, the fighter pilot said that is realistic or not. What was their opinion about?
Decently realistic, yeah, decently realistic. We did all sorts of changes there, like doubling the size of aircrafts, which is important because otherwise the planes would be too small. Because in the real world, you don't really see the planes you're fighting with. Even though you have much higher resolution in the real world, you still can't see them. And in a screen that's pixelated, you'd really literally see just a pixel before when it's time to fire a missile. So we doubled their size so you'd see something when you're firing.
Okay.
And that's sort of the main cheat that we did there. But we also simplified avionics considerably because avionics are really, really, really complex. And if we'd have shown realistic avionics, it would have made just takeoff and landing so hard. I mean, I tried flying the Falcon simulator, which was a contemporary that was much more realistic than ours. And it was unflyable for someone like me, who's not a pilot. And anyway, so one of the things we did there was very much focus on the gameplay. So we flew real missions, real life missions flown by the United States military and in the previous one in the Israeli military. And we let people sort of jump into planes so you could be in one plane and then move to another plane and sort of fly there. And the AI would fly the plane for you. And it was a pretty cool thing, because you can experience real world situations. And I learned so much about I still love a lot of these stories about all these amazing situations in aircrafts, both in civil and in military stories, because there's so much to learn there about how people navigate these insane stories. Like a friend of mine got hit by lightning, a pilot, and was still able to land his plane. And there's a very famous story about an Israeli pilot who lost a wing. And because there was so much smoke, he didn't know he lost his wing and was able to land. And there was another story, that's something that we had in our missions, where during Yom Kippur War, there was a force of about 20 airplanes that attacked an airbase in the south. And there were just 2 planes in the air without missiles. And they were able to chase away 20 airplanes that were fully armed and ready for war, just by luck. And it's an amazing story, that and there's lots of stories like that about how they do all of these things, and it's very interesting. Also, the airplane design, and these are marvels of engineering with all sorts of niches. The story about the first civilian jet, why it crashed. You're familiar with that story?
No.
No, it's amazing. They had the first civilian jet started crashing a few years after it was built. And they didn't understand. There was first crash, second crash, third crash, suddenly they stopped. They said, wait, there might be a problem here. And it wasn't immediately. It was after a few years.
Was it a button or something in the wrong location, right?
No. The windows were square. They built square windows instead of rounded windows. And because a square is inherently a weaker shape because the corner starts deteriorating after a while against the pressure, then the square windows essentially started giving in after a few years. So that's why all windows in airplanes are rounded to give a more even surface against outside pressure. And it's, it's insane that something like that comes up, and it's the small things. And I love these stories. They're so educational.
There's another story. There was an airplane where there was a dangerous button in the wrong place. and it could be accidentally hit, and this causes some problems as well. So
I'm vaguely familiar, but I don't remember that. It's there's.
But
so
what
many
happened
of those,
after why you quit the flight simulator company? What happened afterwards?
So I decided I want to go at it on my own, and I formed a consulting company in '99 and focused on Java, and that's where I really go into Java because that's...
Was 99 the name of the company?
No, in the year 99, the company name was vPrice Consulting. It's so I formed a consulting company and started hiring people. Actually, Gen was one of my first hires there, and and quite a few others. And I just started doing consulting first from my home, and then I got offices and things like that, and started getting lots of jobs. I consulted for over 100 companies over the years back then, and it was intense but very educational. And during the downtime, consulting is a very ups and down sort of situation. I said, I want to build something that's interesting. And my father was a wholesaler and worked a lot with restaurants. So I've always been very obsessed with the restaurant industry. So I spent a lot of time in my youth, in the back of restaurants, and I love, the whole complexity of that. And they always had terrible systems for waiters, sort of touchscreen systems that kind of sucked. And I was really obsessed with Palm Pilots at the time. So I said, okay, I want to build a Palm Pilot application for waiters. So waiters would enter the order in a Palm Pilot and it goes right into the kitchen. Ideal. So I started working on that during my downtime between consulting projects. And I hated programming for the Palm Pilot because it was a very primitive compiler and it was very unpleasant to work with that. And just then Sun came out with the Spotless VM, Spotlets. Which was a precursor to MIDP to J2ME. And I played with it a bit and I said, I'd like to do that. I'd like to program for that in Java. That's so much better. But one of the things I decided about my company was that we were going to use only Linux. So all the computers in the office were only Linux, no Windows, nothing. And Mandrake, obviously. So and the Spotless VM came out with support for Solaris and for Windows. No Linux. Thank you, Sun. So I took the code, which was nice of them to publish, and I just got it working on Linux, which was pretty easy. And I did what anyone would do is I just wrote to the mailing list and said, hey, I just ported this to Linux. I'm not sure if it's legally valid for me to distribute it. If someone can illuminate on that, if someone else wants help with that, I'll be glad to help. That's sort of the gist of it. I don't remember the exact name, the exact text. And like an hour later, my phone rings and it's a guy called Dov Zanman from SIDC, which is the Sun Israel Development Center. Turns out there's a Sun Israel Development Center, which I had no idea. And he says, there's this, and I work there. And according to his recount, I didn't shut up for the next hour, which is very believable. You're hearing me now how I talk. Very believable.
Yeah.
And we talked, and I went and interviewed at Sun, and then started working with Sun for well over a decade. That continued into Oracle as well. And
were you freelancer or you worked for Sun?
I was always a consultant. They offered me a job several times, essentially, which I sort of laughed in their face because you want to pay me less for me to come and become an employee. Get paid less and have less freedom. But I had business cards as Sun. I presented as Sun in conferences. I went to customers, flew with them to abroad and all of that sort of thing. And so I worked as a Sun employee in the ways that mattered.
So you were kind of a spy, secret agent, right?
Yeah, sort of. I had all the benefits without a lot of the drawbacks.
Yeah.
So I didn't get the stock options when they were worth $257 billion, but I didn't have the stock options when they were sold for $7 billion.
Yeah.
So it's, upside downside. But yeah, it was definitely one of my favorite places to work with, and I worked with, as I said, lots and lots and lots of companies.
Suggestion.
It's still my favorite.
We will stop here, and I will re-invite you back as soon as possible for the second part about Chai and Java.
So it will be like 4 or 5 parts if I keep going that way.
No problem. The stories are interesting. So if the listeners say they don't like you anymore, so we will quit. This is my podcast. I can do whatever I like. So we can just keep talking, because it's a nice history. And what you sent me is an video of you from 2007, I think, from Java 1.
8, I think. Yeah.
Yeah. And I also was on the Java 1 back then. And I remember a really nice video. And there are actually lots of videos from Java 1 back then, which is amazing. Yeah, you are a Sun t-shirt. I see this. I have.
I still have the Sun clothes, all of them from back then.
And what I remember in the year 2000, this was the year at Java 1 where they either gave away the Palm Pilot, but there was some Palm Pilot, co-branding with Sun Microsystems, because you could get a Palm Pilot, a Java 1 with Java on it. This is what I remember.
Yeah, they had this amazing demo with tanks that they built with Palm Pilots and laser pointers with Lego Mindstorms. And they had this game where you'd fight with the tanks with lasers, and was all simulated using Java 3D in sort of 3D simulation environment, which was amazing. I didn't go back then, so I didn't see that, but it was pretty cool. Yeah, that was an amazing demo.
Where people can find you, and maybe you can mention already your book, right? So this is unrelated to lasers and Java, but maybe as a to Java a little bit, not to lasers. So mention your book and Twitter. And
it's related to consulting.
Yeah.
Yeah, because lots of times when I say I was a consultant, people don't really have an image what that means. It means going into a company and being the smart person without insulting people. And without humiliating yourself also. And, one of the tricks to being a good consultant is being really, really good at debugging. And I wrote a book about debugging by Apress, which you can find by finding me online at debugagent.com. Also Debugagent on Twitter, on Mastodon, and Shael Morgan LinkedIn, etc. And I also have a course that explains pretty much everything there is about debugging from the very start in the IDE all the way to advanced stuff. And actually in the IDE, if you don't know what's object markers, which most people don't, it's a feature in the IDE and IntelliJ. I just did a video.
No, stop.
Of 16 things.
You have just to promote, because if you would like to talk about this, we have to do this next time. You wrote, to debugging, but where people can find your course right now? You have a link.
Debugagent.com.
Debugagent.com. Okay. But I have to say, the entire discussion was a huge promotion for debugging. Actually, what you said, you did this entire time, at the C++ time with the refactoring or whatever. And I think you are one of the few instructors or trainers who are also able to debug, under fire, right? During a robbery,
I hope
so.
Extreme
conditions. Extreme conditions.
Yeah, cool. I spent a lot of time in the trenches.
I have to invite you back. So thank you for watching. And what's your Twitter handle? Shay
Debug Agent.
Right? Debug Agent. Twitter handle as well. Okay, Debug Agent.
Yeah.
Okay, thank you.